Life of Mine Economics offers life of mine economic forecasting using drag-and-drop modeling that is intuitive and simple to use. The model building process is made fast and efficient through the use of pre-configured templates or building blocks. These building blocks, at minimum, contain all the model logic, relations, and relevant formulas for the model, thus allowing the user to focus their time on the physical building process and entering of data. Cost and labor rules can also be pre-configured, allowing the standards and norms to be managed centrally. The process in which to move through the model is chronologically laid out in the upper tabs. This process more specifically would be Global Settings, which allows for settings of global factors such as metal prices, labor grades, and escalation factors. Model Assembly, where pre-configured templates can be dragged and dropped to assemble a model hierarchy based on client operation requirements. Data Entry. This series of screens allows for population of all costs, revenue, drivers, and cost settings within the model and associated scenarios. Reporting. This allows for pivotable reports to be exported to Excel to allow for all costs to be sliced and diced as required. And Management Dashboards. This series of screens allow the use of various techniques and analytical methods to interpret the model results in detail, as well as allowing for effective comparison between various scenarios. Assembling the model structure is made fast and efficient through the use of pre-configured templates or building blocks. In this example, I will run through how to create a mine structure using the pre-configured entity building blocks. I firstly drag on an operation template. I then drag on the central template onto the operation. Then I drag on Plant 1, Plant 2, Plant 3, and Plant 4 onto the operation. Lastly, I drag on Shaft Complex 1, Shaft Complex 3, Shaft Complex 4, Dump 1, Dump 2, and Dump 3 onto Central. As we can see from the right of the screen, contained within the entity building blocks will be all the relevant activities associated with that particular work area. Each activity will contain the defined costs and revenue elements relevant to that particular activity. Activities can consist of a combination of resource costs, such as stores and utility costs, labor counts and cost, capital costs, and revenue streams. These high-level building blocks are configured during the workshop phase of any project, where this level of detailed modeling can be built to the client's specific requirements. The most challenging part of running and maintaining a model is ensuring that the correct data has been uploaded. I will now run through a brief demo of how one would go about entering data into the model. Life of Mine Economics makes use of the concept of drivers to forecast costs and revenue over the life of a project. Drivers can be anything from the tonnage in a production profile to the number of trucks or equipment that is required. Data entry and accumulation is a cumbersome process and is prone to error and misallocation. This issue is efficiently resolved in Life of Mine Economics through the use of Excel adapters. By clicking on the Create Data template, a full driver template report is exported into Excel. This template can then be populated or linked to exported reports from a mine planning system or the Cyest Mine Scenario Planner, and then re-imported back into the model. This allows for a simple interaction with the model, as most users are comfortable using Excel. Resource costs consist of two parts, namely the fixed and variable cost portions. Fixed costs will remain constant over the full life of the project, or until the particular entity level production stops. The variable portion of the cost is generated using a variable cost rate, which is then multiplied by the defined cost driver. Variable costs will in turn change in accordance with the nominator driver. I will be configuring the electricity cost on the engineering activity. Navigating down the tree and selecting the desired cost, the available inputs become available. I then select total tons to drive the cost from the drop-down menu. Lastly, I enter in historical data in the form of a historical cost, historical driver, and a fixed cost percentage. Based on these inputs, and the schedule drivers imported previously, you will notice from the graph that the cost has instantaneously been updated. Alternatively, you can create an Excel template for all cost inputs in the model. Filters can then be applied for the particular cost. This template can then be saved and re-imported back into the model. Input templates can also be generated for all cost settings within the model. In this template, driver assignments can be made in bulk and then re-imported back into the model. Labor costs are generated by first generating a labor demand. The labor demand is calculated by entering a business rule at a designation level. The individual rules, in combination with a production schedule, generate the required workforce demand to meet the production targets. I will be configuring the P1 underground cost on the engineering activity. Navigating down the tree and selecting the desired designation, the available inputs become available. I then enter in historical data in the form of a quantity of designation, number of shifts, and efficiency. I then select total tons to drive the designation demand from the drop-down menu. Then I select the relevant salary grade to calculate the labor cost. Based on these inputs and the schedule drivers imported previously, you will notice from the graph that the cost has instantaneously been updated. Alternatively, data and settings can be applied to the model through the use of the Excel data adapters, as described previously. Capital numbers can be entered monthly or yearly over the full life of the project, either manually or through the use of the Excel adapters and the generated Excel template report. I will configure the Safety Upgrade Phase 2 capital cost on Shaft Complex 4. Navigating down the tree and selecting the desired cost, the available inputs become available. I then enter in the capital amounts required. Alternatively, data can be applied to the model through the use of the Excel data adapters, as described previously. If detailed capital planning is available only in the first few years of the model, the concept of stay-in-business capital can be applied. This allows for capital requirements to be calculated based on a percentage of the working costs. If the planned capital falls under the specified percentage, capital is automatically topped up. An unlimited number of revenue streams can be defined at any activity level within the model. Revenue numbers can either be defined explicitly or they can be linked to a production driver. I will configure the gold revenue stream on Shaft Complex 4. Navigating down the tree and selecting the desired revenue item, the available inputs become available. From the drop-down available, I select gold produced as the content driver. I then select the global gold price to determine the revenue. Alternatively, data and settings can be applied to the model through the use of the Excel adapters, as described previously. Once all costs and revenue items within the model have been populated, a variety of standard Excel pivot reports can be exported. These reports allow great flexibility, as all calculated costs can be sliced and diced as required. If changes are made within the cost reports after the original export, the report can be updated or refreshed rather than creating a new report, so that all table configurations remain. Standard reports available are the cost report, labor report, driver report, and financial report. If custom reports are required, these can be configured for the model to auto-populate the particular report template with specific cost totals. These reports can then be bundled within the model. Multiple scenarios can be created within Life of Mine Economics to allow for effective comparisons between various options. New production schedules can be imported as a new scenario from the mine planning system or the Cyest mine scenario planner, and the full labor plan and cost budget and forecast calculated. I will create a new scenario for a new production schedule. Firstly, I clone the current scenario. Then, I create a new driver template and populate the template with a new production schedule. This new production schedule is then imported back into the model. Any number of production schedules can be costed in this way, at the push of a button, to compare costs and NPV. What if and scenario capability via datasets allows management to generate multiple budgets and forecasts to test different assumptions and strategies. User configurable management dashboards allow for what-if levers to be adjusted testing changes in the external environment, such as electricity cost escalation or changes in labor rates going forward. Cost profiles allow for a means to view aggregated cost profiles over the life of a project. Profiles can also be compared between scenarios within a model. A very useful analysis tool is that of Waterfall Charts. These charts allow for a visual representation of the breakdown in costs throughout the model and allows for rapid dissection and evaluation of your model. They are especially useful for quantifying cost contribution and drilling down to individual costs. A user can select any entity item for a particular time period and see a variety of costs breakdowns, for example, contribution per entity and cost type breakdown. The value driver tree allows for an extracted view of the model logic. This simplified view allows high-level relationships to be evaluated. Based off the structure of the value driver tree, the high-level sensitivity of the model can be evaluated. This sensitivity analysis exposes the cost elements in the model that would contribute the largest variance if they had to be flexed up or down by 10%. Advanced analytical functionality allows for path of greatest variance analysis to understand the reason for variance between two scenarios using reverse modeling techniques. For more information, refer to our full range of demo videos and brochures on our website at www.cyestanalytics.com.